And next we have another presentation of the day by Rene Boeringer, and everyone with the round of applause, please welcome him on stage. We're going to talk about on the topic common pitfalls to avoid in implementation and operations of MDM and smart prepaid solution. Over to you, sir.
Thank you for the introduction and welcome back after lunch. I was thinking during the lunch, what is the better time slot, before the lunch or after the lunch? So I decided both is not the optimal time, but anyhow, I'm very happy to be able to present here. As usual, I will not do a lot of slides about the company, about Cuculus. I think a lot of people here know us already. So we are delivering software for utilities, only for utilities. We don't do anything else, and that is on the head-end side as well as on the MDM side. Today I brought a very specific topic which is extremely interesting for the Indian market. That is actually the combination of MDM and prepayment. For most of you who started with that subject, it is just another feature on the MDM. I will tell you now that's not the case. It's a completely game changer. So somebody who has experience on prepaid, classical prepaid, so it means non-smart prepayment, cannot really anticipate the problems and the issues actually which you will face here. Why I'm saying that? What's the difference between prepaid and smart prepaid? So prepaid is the version where somebody is just buying a token, get that little token, then he is walking back home and typing this token into the meter, and the thing is done. The whole logic, the calculation is within the meter. There's no dependency on anything, no dependency on the backend system. Smart prepayment is something where somebody is buying the token and immediately it's on the meter. So it's dispatched in the backend system down to the meter. You do even one step further, you are doing even the calculation in India on the backend systems. That creates more dependency, so that means that not only the token needs to go down, but also to calculate the balance of your budget, the meter data need to be back in the system on time, and then also the system needs to take action on time again to switch, for example, the meter off or to inform the customer to update. So that's only the introduction. Sorry. Yeah. So when we are looking at the systems and systems deployment, then most of our customers believe that they can solve everything with a KPI or with the SLA. Okay. So it's not my thing. So I will put an SLA to the customer. He has to the vendor. He has to deliver a system which can support my SLAs, meaning that the data is in the system as expected, that the system reacts in a certain time frame to my commands which I'm sending down to the meter, and then I'm protected. That's not the case. Only one little issue. Yes, you can penalty your vendor, but it will also actually hurt the user, the utility, the DSO at the end. And that is something you cannot banish. So some of the things will maybe just in media and will go all around India. Other things will maybe hurt you so much that you're losing the trust of your biggest customers when not handling that in the right way. We will have some examples we are coming up with later. So it's better to handle it and to tackle it, to implement it in the right way, so that you're not just running into the issue that something unexpected, you think it's unexpected, will hit you afterwards. We have a lot of really good bases here in India to implement that. So there's a lot of support from the government that is also not given in all the regions and all the countries where we are working. And that actually allows also to implement a good system design. But on the other side, also India is lacking the problem of tenders. Tenders are made to make the offers comparable and to avoid any kind of influence which is hurting the investments of the government or the DSOs. But on the other side, it also avoids in many times to have really good systems. That is actually based on the assumption that first of all, tenders dividing systems. But here you have to provide a whole solution which only works if all the different elements in the chain are working together. That's the definition of the system. But if you tender and give SLAs on one piece, on another piece, and on the third piece, that will never work smoothly together. You will have a lot of problems with it. On the other side, you're creating price competition, and this price competition leads to mitigation of quality and of experience in the whole setup and in the implementation. And also that actually gives a chance to people just to try things out on the back of a DSO or of a utility. So we have here some typical issues we were able to witness, and just in case somebody thinks that is related to the issues you have also seen here in India, that is purely coincidence. So sometimes we have issues that, for example, customers are trying to top up their budget, their accounts, their meters, and then it's actually not working because you have a problem on the side of the system, of the backend system. And this problem could arise due to the fact that somebody saved some money in the dimensioning or in the setup of the solution. For example, HA is missing or DR is missing. HA means high availability, so the system is up all the time. And DR means disaster recovery, so that's another system which would jump in and solve the problem or take over the load if the first system is down. HA itself cannot solve everything. That is also a myth, right? So people think if my system is highly available, so it means several services running and synchronizing each other at the same time, then the thing is solved. It's not, because it's also synchronizing problems. So in case you're getting wrong data into the system, for example, in command to switch off devices, or a wrong measurement which is coming into, I don't know, a wrong factor in the analytics or in the event management, then this failure will also be synchronized immediately to the other system, so you cannot stop the system to do the wrong thing. So in this case, you have to switch over to a disaster recovery center, which actually needs to be at least able to take your minimum load. And that means also, of course, it generates costs during the whole lifetime of the project. And that's actually where the cost cutting hurts the implementation. Another one, this is hardware dimensioning. So the system in the most of the cases is dimensioned to what we call the happy flow. So somebody is calculating what would be the typical amount of messages which are running through the system to be able to handle my complete customer demands. And based on that one, hardware dimensioning is given and provided in the project, and the project will be implemented based on that one. But then you are facing peak load situations. For example, after an outage, typically you have a peak load situation. Maybe you get on prepayment also some strange customer behaviors. I would say strange, it's not really strange, but let's assume a lot of people come to the idea just in front of the final match of cricket to top up their meters to be able to watch TV. Nice peak load you have to deal with, and this peak load is not only on the consumer apps. That peak load will be in the MDM, and that peak load will even go to the head-end system and to the metering network, to the AMI network, because we have a smart prepayment solution in place. So the requirements to the MDM as well as to the AMI network as well as to the head-end system are completely different. That's another one where if something is happening, a failure is happening, maybe the system takes a lot of time to recover. Because you thought at the beginning when the MDM was selected, it's fully enough to have a batch-based process. Yes, for billing it is. For the classical standard MDM feature, which is just used to calculate billing determinants to send it to the billing system, it's fully enough to calculate that once a night, maybe even longer. Normally I'm saying for an MDM system, which is just used for billing, I don't care for high availability, 99% or something like that. It can be down 29 days a month. If it's up the 1 day where you're gathering your billing determinant and then send it back to the billing, it's done. But this prepayment is changing everything. Now it needs to be there the whole time because you're calculating actually the budget and the account of the customer. And if a system has an incident, so it's off, and you have to get it up and running, but your recovery time is maybe just an hour, but your next batch process is after 12 hours or after 16 or 24 hours, of course, you cannot satisfy your customer requirements and your demands. You have to wait a very long time, and it's much, much longer than actually needed. Another one, let me see if we skip that. Yep, we'll skip that one. Okay, so load balancing is another one, which can also cause some problems. Load balancing is an extremely tricky element when you have that really online processes. Again, if it's offline and you're calculating, you have a lot of time, you don't need to take care of synchronization of process data. What's a process data is somebody is topping up his meter, he wants to have the meter activated, he wants to have that the head-end system and the MDM knows the new budget. So that's a process, and this data need to be in sync all the time. If only one system in that chain is out of sync, is not able to process the data in real time, then all the other systems get problems. And if something is out of sync, and to sync that, let's say in an artificial way at a later point in time is extremely difficult in such systems. So again, here we are switching, by adding this prepayment to the MDM solution, we are switching from a pure database thing into a process-oriented thing. All the load balancing will be extremely difficult to make, because now for every single step of processing data, you need to know to which process it belongs to, and to make sure that this instance which is taking that part of the load gets all the information of that process, and not a little bit is on the left side, a little bit is on the right side. That needs to be synchronized. So we have actually summarized that into 10 points, how and what you should consider actually when you're designing such a solution. If that is a pure MDM or if that is a MDM with prepayment, it doesn't matter. So there are all the time some key steps you should undertake. First of all, you should never just design for the happy flow. Design for peak loads. That is very easily said, because what is the peak load? What is really hurting your system is the first step you have to define, and then derive from there which part of the system need to dimension in which way. The second one, you will get that peak loads. Even if you design something right now and you consider your peak loads, definitely the next unknown peak load will be just around the corner. And then you need to be able to react with the solution. The solution needs to be able to react. So expect the unexpected. Don't save on hardware. Very, very specific topic I see, especially in India. Hardware is a very small cost of the overall solution. Of the total cost of ownership, hardware is negligible. But everything really, or a lot of focus is on saving hardware. That's maybe sometimes because we have a discussion about cloud or non-cloud solution. When it is good to use a cloud, when it's good to use an on-prem solution. Of course, in the amount of data we are dealing here with, an on-prem solution is always much cheaper than a cloud. But a cloud, on the other side, can maybe deal with peak loads much better than an on-prem solution. But in some, storing information and dealing with information here, in terms of the required hardware, is really a small piece of the cost, but it can generate you a lot of problems if you're saving, for example, HA implementation, if you are saving the disaster recovery setup, or you're just dimensioning it too low, it can generate a lot of downtimes. The point number 4 is considering process-to-process interaction or interrelation. So the processes where most of the SLAs are based on are not isolated. Processes are impacting each other. For example, you have your standard meter reading process, and this process will be impacted by, for example, such a peak load of switching on the, meters or topping up the budget of a customer. Which one is the one which should have priority? Most of the smart meter systems have SLAs mainly based on the standard meter reading. The standard meter reading is the one which has the least SLA requirements. In reality, as I said, you need to have the things for billing, not every 5 minutes or 50 minutes. But what is very important is that your events are going through, that you're knowing which parts of the networks are off, that you get confirmation from the system which command has been executed successfully and which not. Right? Just imagine if this confirmation is not coming through, what the system is doing, the MDM. After it's repeating the activity, it's repeating it. It's due to a fact that something is overloaded and the system is not able to get the answer back, it will re-trigger it, so it makes the situation even worse. This is a disaster for every kind of meter reading network. So this is a point I have not talked about, how that the ownership of a process need to be defined. If that is in the MDM or in the head-end system, is another topic. We have actually point number 5 we have already addressed. So which service and which solution really needs to be treated at which point in time. So you also need to have priorities to the data and the processes. And these priorities might change. Depending on the situation, depending on the issue you have, maybe certain data is more important and other data is not so important, or a process is important to just keep the system again up and running. Or we are differentiating between security and safety issues, for example. Point number 7 is the 0-day thing. So the 0-day thing is something which is normally known in the security environment. So that says there will always be something you have not expected. And the system design need to be as such that you can deal with such an event in a way that your impact actually is the lowest you can get. This is also true for a smart metering solution in general, not only for the security. If something is happening in the system, you need some time to detect the issue, and then you need some time to resolve the issue. Right? So you can have something really good in detecting the issue, but your system is not really failure-proof, so you need a lot of time to get the system up and running, and then actually the overall time is also very, very long. If you are not able to detect it in a good way, but you are able to repair it in the same very fast, then you are also running in the same problem. The overall sum of your system downtime is extremely long. And system downtime, again, is not something where your server is down. I'm talking that a certain process where you think it's important, like prepayment, is not working, so people are calling the help desk and complaining, or in the worst case, they even miss the cricket match. So that means actually the monitoring of the overall solution is extremely important. And if you monitor something, again, you need to know what you're monitoring, where the issues can come up. And that will be different from project to project because it depends on the technologies you're using. It even depends on the tariff which is offered to the end users. It is also depending on the behavior of the end users. Huh? Again, remember the cricket game. And if you do that, then you should over the time get to something which helps you to minimize the MTTD, which is the mean time to detect an issue. And that actually can help you to also, at the end, also reduce your overall downtime of the solution. So the last one is to really focus also on the mean time to repair. And mean time to repair means how fast you have the system up and running. So for example, in a case where your whole system is down, including the HA solution, so how much time you need to switch to the disaster recovery. And since the disaster recovery should not be synced automatically, it should not be synced in real time, because otherwise you would also sync your problem, you have a natural gap in between. How big is that gap? How fast you can really switch over to the second system? It's a manual activity, somebody has to decide it. Every switching to a disaster recovery has a certain cost, because later on you have to switch back. And all your processes which are ongoing during that switching time, you might lose. Nobody can dream of a completely automatic failover process where none of the prepayment activities of the customer get lost. You're dealing with hundreds of millions of activities, of payment actions per day overall the country. So you will probably lose during such a switching action millions of payment actions. And since it's the money of the customer, he will complain about it, and you have to handle the complaints. So there's a lot of things you can improve actually to help the DSOs or the utilities in general to get down the cost of the overall solution. So these are all hidden costs, and these are all things you can change. You can help to get down the TCO, and they are only related to the software on the back-end side. It's a very, very small piece in the overall budget of smart meter rollout in India, but an extremely important one. And I wanted to present this small insight here because I think it should get much more attention than it has at the moment. So please do not only focus on the portion which has the highest cost allocation right now, because maybe a huge cost allocation can come through the back door if the overall system design is not set up in the right way. Thank you. That was what I wanted to share. Thanks for listening, especially after that.
Thanks, Rene, for a wonderful presentation. It has given us some insight about how we are moving presently with placement of MDM in particular. Okay. I would say that we are not in infancy, but we have started the smart metering, and we have got some experience where to place the MDM and in whose scope it has to be. Okay. So in India, we have reached a conclusion sort of, maybe not the final one, because still we are in the learning stage. That MDM has to be placed in the AMI-SP's scope, and for the utility it means multiple MDMs. Okay, so the other thought on the other side is that the MDM has to be placed with the vendor who provides the billing engine. Okay, so two different designs, totally different. Pros and cons with both the designs. But as of now, we have reached a stage where the MDM has to be placed with the AMI-SP. So I just want your thoughts about that, and what will be the difference in performance of the two systems.
Okay, thank you. So I think the point of placing that, or the decision to placing that with the AMI-SP is a good one, especially looking into that interrelation between the AMI network and the MDM functionality. So the MDM has control over everything, as per our definition, about everything what is related to customer processes. So that is actually everything what's related to billing, on-demand meter reads, prepayment, switching off because of other activities. That's all related to customers. So that should be in the control of the MDM side, of the MDM, and that has a direct link to the head-end system and to the AMI infrastructure. So if that is in two different hands, there will always be the blame game. Right? The relation to the bill is actually quite a loose one, so there is not a lot of dependency. Right? So that's that you can still do in batches. This is not a very tricky integration task.
The second one, the MDM CCB side integration, not much of a problem.
Yes.
Okay, thank you.
So I think here.
Hi Rene, very good evening. So my one question was, see, all the issues that you have listed down, okay, these all issues are because the logic of the prepaid lies in the server or in the server side rather than the meter being a server. See, now the communication being of the highest, this one, where you have the cloud, you have the fog, you have the dew technology and all that thing happening. So why can't we have the logic placed there when once the power is restored, so automatically the reading can go back to the MD. It's just a suggestion because even our 159.2 doesn't support that. It clearly says that the servers, on the server side only the logic should be placed. So my opinion or my way of suggestion is, why can't we build it on that side? Being industry domains, so you can definitely suggest that the logic should be placed there, so that in case there is anything that we want to communicate with the meter, we can do it through the Bluetooth.
Yeah. So indeed, I mean, three ways actually existing. So one is where the logic is completely on the meter. Some countries, by regulation, enforce to have this. Other countries enforce to have it in a backend system. And there is something in the middle which is called a shadow calculation. So the meter is also doing that calculation in case the connectivity is interrupted, because in the case where the calculation takes place in the backend system, it's not only that the power needs to be up, it's also the communication network need to be up and need to be in sync all the time. But there are also optimizations which are often, let's say, a little bit over top. It needs not to switch off customers in real time, right? So there could be a buffer which is used, and if the customer is using some energy because the mobile network was down or whatever is used, the RF network was down at this point in time, then he might pay it with the next top up. So you're deducting it immediately, but all of these logics need to run through the regulator, and the regulator need to decide what is the most trustable place where the calculation takes place, because you are touching the money of the consumer, right? So that's the decision, and it's made in a certain way for India, at least at the moment, and that's backend calculation. It has also maybe something to do with the complexity it would introduce on the meter side.
Thank you.
Thank you, sir. Thank you. Thank you very much, Rene Boeringer, sir.